My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about problem solving on Shannan Fano coding. Before going to this one, we have to define what is Shannan Fano coding and what are the applications. Then only we will go for the problems. So, Shannan Fano coding, named after Claude Illwood Shannon and Robert Fano, is a technique for constructing a prefix code based on a set of symbols and their probabilities. It is suboptimal in the sense that it does not achieve the lowest possible expected code word length, like Huffman coding. However, unlike Huffman coding, it does guarantee that all code word lengths are within 1 bit of their theoretical ideal I of x equal to minus log of p of x. So, what is Shannan Fano coding and what is the solution for this one? So, Shannan Fano full name Claude Illwood Shannon and Robert Fano is a technique for constructing a prefix code based on a set of symbols and their probabilities. Okay, anything probability. What is the probability of that one? So, if I am taking any of the equation, what is the probability? If probability equal to 1 or if probability equal to 2, like this. Okay, so prefix code based on a set of symbols and their probabilities. It is suboptimal in the sense that it does not achieve the lowest possible expected code word length, like Huffman coding. However, unlike Huffman coding, it does guarantee that all code word lengths are within 1 bit of their theoretical ideal, I of x equal to minus log of p of x. Okay, any of them, if I am taking, suppose x1, x2, x3 or anything, it is code word is a 1 bit, 0, 1, 0, like this. Any of them, 0 or 1, okay, like this. So, in Shannan Fano coding, the symbols are arranged in order from most probable to least probable, and then divided into two sets whose total probabilities are as close as possible to being equal. All symbols then have the first digits of their codes assigned. Symbols in the first set receive 0 and symbols in the second set receive 1. As long as many sets with more than one member remain, the same process is repeated on the sets to determine successive digits of the codes. When set has been reduced to one symbol, of course, this means the symbol's code is complete and will not form the prefix of any other symbol's code. So, what is saying that Shannan Fano coding? The symbols are arranged in order to from most probable to least probable. Suppose I am taking x1 or x2, x3, x4 like this, or A, B, C, D or any of the symbols in order to from most probable to least probable, and then divide into two sets whose total probabilities are close to the possibilities are being equal. All symbols then have the first digits of their codes assigned. Symbols in the first set receive 0 and symbols in the second set receive 1. So, if I am taking the first set, set 1 and set 2, so the symbols in the first set receive 0 and the symbols on the second set receive 1. And as long as any sets with more than one member remain, the same process is repeated on those sets to determine successive digits of their codes. And a set has been reduced to one symbol, of course. This means the symbol codes to complete and will not form prefix of any other symbol's code. So, if I am taking a sets, set 1, set 2, like this. If I am taking set 1, 0, set 2 equal to 1. So, any of that one probability, what is a probability? Is the probability equal to 1 or probability equal to 2? What it will be? So, any of that one, we have to take suppose x1, x2, x3 and x4 like this. So, what are the values are there? Suppose I am taking x1 equal to 0, 0, 0, 1, 1, 0, 1, 1. So, what are the probabilities are there? So, it is a 2 bit of length, it is a 2 bit of length, it is a 3 bit of length, it is a 3 bit of length, like this. So, the algorithm works and it produces fairly efficient variable length encoding when the two smaller sets produced by a partitioning are in fact of equal probability. the one bit of information used to distinguish them is used most efficiently. Unfortunately, Shannon Fano does not allow produce optimal prefix codes. For this reason, Shannon Fano is almost never used. Hoffman coding is almost as computationally simple and produces prefix codes that always achieve the lowest expected code word length. And Shannon Fano coding is used in the implode compression method when it is desired to apply a simple algorithm with high performance and minimum requirements for programming. So, any of the algorithmic work, it is produces fairly efficient variable length coding. Suppose I am taking x1, what is a variable length coding? 2. I am taking x2, what is a variable length coding? 3. x3, variable length coding is 4. So, two smaller sets produces by a partitioning are in fact of equal probability. The one of bit information used to distinguish them is used most efficiently. Unfortunately, Shannon Fano does not allow produce optimal prefix code for the reason. Only only with the help Shannon Fano only getting the prefix code. So that is the problem of some disadvantage is there to produce optimal prefix code. For this reason, Shannon Fano is almost never used. So it is a drawback of this one. So prefix is a drawback for the Shannon Fano. So that is the reason we are using Huffman coding for the better results. Why? Because it is no need of any prefix values. So we are never using for these conditions, for optimal prefix conditions. So Huffman coding is almost a computationally simple and produces prefix codes that always achieve the lowest expected code word length. Shannon Fano coding is used in the implode compression method where it is desired to apply a simple algorithm with high performance and minimum requirements for programming. So if I'm going for the Shannon Fano with the better results of prefix optimal values, but it is used in implode compression method. So okay, already Shannon Fano, Huffman, we are going for the image compression methods only. Definitely these are using for the image compression. So it is designed to apply a simple algorithm with high performance and minimum requirements for programming. So I am taking one example of Shannon Fano coding, then we can understand betterly. The source of information, it generates the symbols A0, A1, A2, A3 and A4. Okay, so the source of information. What is the information? That symbols are A0, A1, A2, A3 and A4. So like this, A0, A1, A2, A3 and A4. So what are the corresponding probabilities? So for A0, what is the probability? 0.4, A1 0.3, A2 0.15, A3 0.1, A4 0.05. So the encoding the source symbols using binary encoder and Shannon Fano encoding gives. So it is a probability values. What is the probability of binary code is a? It is a binary code is 3. What is a word length is 3. Here length is 3. Length is 3. Length is 3. Here also length is 3. So it is a binary code of length 3. Here what is the average of probability equal to 2.0087. It is a L average. So symbol average and the probability of average and the binary code length, it is a Shannon Fano value. So it is a Shannon Fano values. So how we are getting these values, we'll discuss now. The entropy of the source is capital H equal to minus of I equal to 0 to 4. So how much is there means I not to 0 to 4. So 0 to 4 means I equal to 0, 1, 2, 3, 4. How many are there? 0 to 4. Here also A0 to A4 like this. Okay. Summation Pi, probability of Pi, log 2 of Pi values is equal to 2.0087 bits per symbol. It is the entropy. Okay. So we know the entropy. How we got the entropy equal to 2.0087 bit per symbol. So how we got means we are getting from probability values of the given. So we have 5 symbols are there. You can see here how many symbols are there. A0, A1, A2, A3 and A4. So total 5 symbols are there. And 5 less than 8 is equal to 2 cube. Why? Because 3 is there. So I am taking the maximum probability values are 8 I am taking. So 5 less than equal to 8 is equal to 2 cube. Is it okay? Then we need 3 bits at least to represent. Why? Because here all our 3 bits are there to representing. So 5 is less than 8. Okay. 5 is in between the 4 and 8. So it is more than 4. So actually the bits are in between 2 square and 2 cube. 2 square equal to 4, 2 cube equal to 8. But if 4 is not equal to 5, no. 4 is already reached to above reached to 5. So it is reached to nearby 3 bit. That is a 2 cube. That is a 8 bit. So it is a 3 bit of values, and at least to represent the each symbol is a binary fixed length coding, and the average length of the binary code is L average equal to summation I equal to 0 to 4 Pi into Li equal to 3 of 0.4 3 of 0.4. Why? Because it is a 2 cube 3 bit. 0.4 plus 0.3 plus 0.15 plus 0.1 plus 0.05 is equal to 3 bit per symbol. So what is the efficiency of the binary code? Efficiency nu equal to h by L average. Already we know that what is the h value here. Already we know that h means entropy. So here entropy equal to, it is from probability. Entropy came from Pi. So if you know the probability values, then we will easily get the entropy values. So here capital H of L average. So nu equal to entropy is by L average. How much bits are there? 2 cube. Already we know that 2 cube equal to 8. So 3 bit of data is there. So you can observe here everything we have the 3 bit data 0 0 0 like this. Okay. The what is the code length is a 3 like this. Okay. So Shannan Fano coding is a top-down approach. Constructing the code tree we get. If you are going for the top to down approach, why? Because you can see here increasing to decreasing order 0.4, 0.3, 1.5, 1, 0.05. So increasing to decreasing. So that is the reason we are going for the top-down approach to construct the code tree. We get the average length of the Shannan Fano is L average equal to I equal to 0 to 4 Pi into Li. That is a 0.4 plus 0.3 into 2. So 0.4 into 1. 0.4 into 1. So 0.3 into 2. 0.3 into what is the length here? 2. Here length 1, 3, 4, 4. Okay. So 0.4 into 1. 0.3 into, you can see here, what is the code length? 1. Here code length 2. Why? Because 1 0. Here 1 1 0. 3. 4 code length. Here 4 code length. So 0.4 into code length equal to 1. 0.4 into 1. 0.3 into 2. 0.3 into code length 2. Here 0.15 into 3. See here 0.15 into 3. Here 0.1 into 4. 0.1 into 4. Next 0.05 into 4. So 0.05 into 4. What is the value? 2.05 bit per symbol. So that is the average length. Average length L average equal to 2.05 bits per symbol. So 2.05 means around round figure is a 3 bit per second. We are already taken as a 3 bit. So the efficiency of the Shannan Fano coding is efficiency nu equal to h by L average. So h by L average. Here 2.0087. Already we know that 2.0087 divided by what is the L average? 2.05. Already we got this value. So it is a 98%. In the previously we got 67%. Now I got 98%. So it demonstrate the efficiency of the Shannan Fano encoder is much higher than that of the binary coding. So first I got the 67% in the first stage. In the second stage, I got 98%. Is it increasing or not? As 67 to 98. So it is an increasing order. So it demonstrates the efficiency of the Shannan Fano encoder is higher than that of the binary encoder. So when I am going for the example 2, this example shows the construction of a Shannan Fano code for a small alphabet. These are 5 different source symbol. Suppose 39 total symbols have been observed with the following frequencies, from which we can estimate the symbol probabilities. Okay, estimate what is our aim is means estimate symbol probabilities. Estimate the symbol probabilities. So how we are estimating? Here already the question is symbols. How many symbols are there? A, B, C, D, E. How many symbols are there? 5 symbols. Five different source symbols. And what is the count means? 15, 7, 6, 6, 5. So 15 plus 7, 22, 6, 28, 34, 39. So 39 is there? Yes, I got the 39 total symbols. So what is the probability? 0.385, 0.179, 0.154, 0.154, 0.128. So what we have to do? We are estimating the symbol probabilities. Okay, 5 symbols are there, 39 total symbols are there. Then what is the result? We have to find out the symbol probabilities of this one with the help of Shannan Fano coding. So the entropy, already we know that capital H of x equal to 2.186. Already from this one we are getting the average equal to 2.186 bits per symbols. So the Shannan Fano code, we need to calculate the desired word length Li equal to minus log 2 of Pi. Pi is nothing but a probability. What is the probability here? In the question already given 0.385, 0.179 like this. Okay. So what is the probability? Symbols are the, already we know that in the question only A, B, C, D is there. And the probability also they gave. But we have to find out the entropy. So the Shannan Fano calculate the word length Li equal to log of this one. So what is the length? Here Li equal to length. I am finding out in the length from the minus log 2 of Pi means 0.385 minus log 2 of 0.17 minus log 2 of 0.1.5 0.1 minus log base 2 of 0.128. So what are the values I am getting? 1.379, 2.480, 2.7, 2.7, 2.9. So what is a word length? Equal to minus log of 2. So 1.3 is nothing but it is around 2. 2.4 is nothing but a 3. 2.7 is a 3. 2.7 is a 2 point something means 3. 1 point something means 2. 0 point something means 1. So 2.9 something is nothing but a 3. It is like a round off. Okay. It is like a round off value. It is the exact value. So what are the word lengths are there means the word length is a 2, 3, 3, 3, 3 like this. Okay. But we can pick code words in order to choose the lexicographically first word of the correct length that maintains the prefix free property, clears a gets from the code word 00. First I'm taking the code word is 00. To maintain the prefix free probability, B's code word may not start 00. So the lexicographically first available word of length 3 is 010. Continuing like this, we get the following code. So in the question, they give the symbols and they give the probability values are there. But here I am getting the, from the symbols, from the probability, I got the code length or word length of this one. When I am getting the code word or word length from the picking the lexicographically first word of the correct length that maintains a prefix property. Always Shannan Fano is nothing but a prefix. Shannan Fano is nothing but a main name is a prefix free or prefix values are getting from the code word. And to maintain the prefix free probabilities, the code word may not start 00. So the lexicographically first available word of length 3 is 010. And continuing like this, we will get the following code. So it is continuation of this one. So you can observe here, what is the code length here? 2. Here code length is 2. Here 3, 3, 3, 3. Okay. So code length 2, 3, 3, 3, 3. Okay. So what is the code word? 2 is nothing but I am taking as a 00. What is the 3 value here? 010, 011, 100, 101. Actually, I am freaking from 0.385, 0.179. So increasing to decreasing values are there. But here what I am doing, increasing to decreasing here. Here I am going for a decreasing to increasing value. 0 0 0 1 0. After the one, what you are getting? 0 1 1 1 0 0 1 0 1. So code words are increasing here. Here the values are decreasing here. Here decreasing. Here I am increasing. So alternatively, we can use the cumulative probability method. So when I'm using the code words like this, code word and code length in binary, what is happening here? 0 0 means 0.00, 0 11 means 0.011, 100 means 0.100, 101 0.101, 110 means like this. Okay, so after this one, you can observe here 000, 00, 10, 11. It is a code word length in binary form. Okay, in the symbols I know, probability also I know. So what I found means I got the word length and binary length. Binary length is nothing but a code word. It is nothing but a code word. So the code word under the two methods are different. The word lengths are the same. We have lengths of 2 bits for A and 3 bits of BCD and E given in the average length. So what are the minimum bits are there? 2 bit is there and 3 bit is there. Total how many are there? Only 2. That is a 2 bits and 3 bits. Okay, we can observe here. It is a 2 bit, 3 bit, 3 bit, 3 bit and 3 bit. So maximum of 2 bits are there and 3 bits are there. So what is the 2 bit value here? Here 2 bit value is a 15. So we can see that we can take the values of 2 bit value is a 2 bits of 15 plus 3 bit values. How many are there? Remaining all 3 bits. What is the probability value? In the question we can see 7 6 6 5. So 7 6 6 5. Total how many symbols? 39. In the question only they given 39 symbols are there and 5 symbols are there. So 5 probability values and 39 symbols are there. So 2 bit into 15 is equal to 30 plus 3 bit of this one. 7 plus 6 plus 6 plus 5. So total divided by 39. What is the value? 2.62 bits per symbol. 2.62 bits per symbol. How many symbols are there? 5 symbols are there. So 5 symbols. Each symbol 2.62 bits per symbol. You can understand. Total 5 symbols. Each symbol is at 2.62 bits. Total 5 symbols means 5 into 2.62. That is the total probability of that one. So the expected word length is that expected length EL equal to summation I equal to 1 to n PI into LI less than or equal to I equal to 1 to n PI of minus log 2 into PI plus 1 is equal to minus of I equal to 1 to n PI into log PI base 2 plus I equal to 1 to n PI equal to capital H of x plus 1. Okay. So what I got with the total value? 2.62 plus 1. What is the equation way? What is the formula means? I got this one. Already we know that probability of this one. Already it is a code word. Okay. So H of x plus 1. It is a total probability. So 2.62 bits per second into 5 into this one 2.62. So that is a probability value. Okay. So example 2. Symbols are given A, B, C, D, E. So from the continuation of this one, we can observe like this: 15, 7, 6, 6, 5. 15, 7, 6, 6, 5. Continuation of this example. I am taking another method. So we can observe all the symbols are sorted at the frequency from left to right, shown in the figure. Left to right we can see. Putting the dividing line between the symbols B and C, the results are 22 in the left group and total 17 in the right group. So total 15 are in the left, total 17, 6 plus 6 12 plus 7 19 and 5 22 symbols are there. So 17 and 22 are there. B and C results are 22 and 17 are there. So 22 and 17. 6 plus 6, 12 plus 5. It is 17 and it is a 22. So 22 and 17 symbols are there, and it minimizes the differences of total between the total two groups within the division. A and B will each have a code that starts with a 0 bit, and CDE codes will starts with 1 as shown in figure B. Subsequently, the left half of the tree gets new division between A and B, puts A on a leaf code 00, B on the leaf code is 01. When I'm taking either A equal to 00 and B equal to starting from 01. Okay. So in the top of this one, how many symbols are there? 5 symbols are there. These are sortedly from left to right and putting dividing line between the symbol B and C. So we are dividing as a 2 and 3. So A plus B, how many? 22. Remaining C, D, E are the 17 are there. When we are minimizing the differences in total between the two groups, that is A group and B group, A leaf and B leaf we are calling, and these are the bit values are 0 and 1. When I am going as a 0 or 1 or 00 or 01, and the new division of A with B with 00 and 01. A is 00 and B is 01. Otherwise A equal to 0 and B equal to 1. After 4 division procedures, a tree of codes results in the final tree. The 3 symbols with the highest frequencies have all been assigned 2-bit codes, and 2 symbols with lower counts have 3-bit code as shown in the table. A, B, C, D, E. Probability is 0.3, 0.1, 0.1, 0.1 and 0.1. First division, it is one question. So in the discussion already there, AB is a one group, CD is a another group. Here already we discussed here. AB is one group, that is a 15 plus 7, 22. CD is another group, that is a 17 values. So 0, this code value is 0, it is a 1. So it is leaf 1 and it is a leaf 2. So second division, we are dividing as this one. This 0 and again this I am dividing as a 2 divisions, that is A and B, 0, 1. Here I am dividing as a separately 0 and 0, 1. Okay. So final code word for A 00, for B 01, C 10, D 110 and E equal to 311. So it is dividing as a 2-bit and a 3-bit code word. Why? Because here these are belongs to 0. That is the reason I am getting 2. Again, this one is dividing as a 0 and 1. So when I am going for the 0, that is a 2-bit word. When I am going for the 1, it is a 3-bit word. Okay. So it is a 0 value. So that is the reason 2 bits are there. Here 1 value is there. So 3 bits are there. But here 1 is dividing as a 0 and 1. When I am going to the 0, 2 bit. When I am going to the 0, 2 bit. When is 1, 3 bit. So 1 belongs to 110, 311. So how many 2 bits are there? Here remaining 00, 01, 10 are the 2 bit. How many 3 bits are there? 110, 311 are the 3 bit. So we can see here the 5 symbols. 5 symbols. Here 5 symbols dividing as a and B, 2 and 3 symbols. Again, these 2 and 3 symbols I am taking as a 2, 1 and 2. Again, these are in as a, this is 1 and this is 2. So okay, when it is going as a 1 means it is a 2-bit, 2-bit and a 3-bit. Okay. So A, B is one group, C is another group, D is another group. So finally what happened means A, B, C. A, B, C. It is one group and D is one group. So A, B, C one group means 2-bit and C is one group means I am taking as a A, B, C is a 2-bit. It is a 3-bit. Okay, like this. So the results of 2 bits for ABC per 3-bit per DE given in the average length equal to 2 bit is equal to, so how many 2 bits are there? You can see how many 3 bits are there. We can observe here. So here 2 bits are taking 15 plus 7 plus 6. A, B, C. 3 bit how many? D and E. So what are the values of A, B, C? We can see in the question. A is the 15, B 7, C equal to 6. 15, 7, 6. 15, 7, 6. Plus how many 3 bits are there? See in the question. 6 and 5. D, E. How many are there? 3 bit. 6 plus 5, 3 bit. Total how much equal to? 2.28 bits per symbol. How many symbols means? Total 5 symbols with the average of 39 total symbols. So the Shannan Fano method is the average length of 2.28. So average length equal to 2.28, and output is a Shannon's method to the average length of 2.62. So total is a 2.26, and Fano method is a 2.28 total, and the Shannon method it is a 2.62 symbols, bits per symbol. Okay, it is a total length and the Shannon Fano length. Another example, the given task to is construct Shannon code for the given set of symbols using Shannon Fano lossless compression. Already we know that how many lossless compressions are there. So lossless is a Huffman coding, Huffman, Shannon, Fano, and so many are there. We will discuss on that time. So here Huffman coding already discussed, Shannon Fano already discussed. These are under lossless image compression methods. So in the question they gave symbols are A, B, C, D, E. These are the 5 symbols are there, and the probability values are 0.2228, 0.15, 0.30, 0.05. So Shannon Fano code. So already they given the code 00, 01, 10, 110, 111. So it is a 2-bit code length, 2 bit, 2 bit, and 3 bit. It is a 3 bit. So the symbols are A, B, C, D, E. Probability of frequency is 0.22, 0.28, 0.15, 0.30, 0.05. So these symbols and their probabilities of frequency are taken as a inputs. So these are I'm taking as a inputs values. Okay. So I'm dividing as a increasing to decreasing order. Increasing to decreasing order. Increasing to decreasing. So 0.3, 0.28, 0.22, 0.15, 0.05. So increasing to decreasing order. Increasing to decreasing. So when I'm taking that 0.3, 0.28 dB. So how many bits are there in the dB? D is a 3 bits, B is a 2 bit. Okay. So dB I'm taking as a 2 and 3 dividing as a, first I'm dividing as a 2 plus 3. So 0.3 and 0.28 I'm separately I'm taking these two, and 3 I'm separately I'm taking like this. The symbol are divided into 2 such that the total probability frequencies. So from the Shannon Fano we have to divide as a 2 groups, any of this one. So that is a leaf 1 and leaf 2. So in the leaf 1 we have to take 2, and the leaf 2 we have to take a 3 most probably. As per symbols are dividing into 2 groups, the total probability or frequency of left side almost the same as that of a right side. So left equal to right, almost I'm taking like this. So 0.3, 0.28 is the leftmost. Okay, it is a leftmost, and it is a rightmost. 0.22, 0.15, 0.05. So what is the root of the total value? So it is a DBACE, 0.3, 0.28 total probabilities are there. It is from leftmost and rightmost. So when you're taking the left equal to 0 and right equal to 1, always we know that 0, 0 and 1. If I'm taking 1, 0 and 1 like this. Okay. So if it is 0, 0, then I'm taking as a 0 and 1. So this value is 0 and this value is 1. So it is a level 1. Level 1, 0 and 1. 0 and 1 is a level 1. Okay, it is a level 1. Next we have to go for the level 2. So in the level 2, what is happening? D and B, D and B, it is 0 and it is 1. 0 and 1. So in the level 1, what is happening? These two is 0 and 1. Okay. So 0, how many zeros are there? Here 2. So it is a 2 bit. Here it is a 3 bit. And it is a 2 bit. And it is a 2 bit. So how many 2 bits are there? Means 2 bits are 2 bits equal to D plus these are the 2 bits, and these are also 2 bits. Why? Because 1 is divided as a 0 and 1. So this one plus A plus C are the 2 bit, and how many 3 bits are there? Means E is a 3 bit value. Okay, we are dividing as a root level 1, level 2. So it is the probability of the Shannan Fano coding. So in the today we discussed Shannan Fano with the help of techniques of algorithms for the prefix code based on the set of symbols and their probabilities. What is the condition of the Shannon Fano is nothing but we have to take the prefix code before to solving of this one, and what are the probabilities of them? What is the ratio of probability? We have to finding out from the Shannon. But which one is best compared to Shannon or Huffman? Means Huffman coding is a better one compared to Shannon. But through some conditions, if I have to find out the probability with the prefix code, Shannon Fano is better. If I don't have any prefix values, then we are going for the Huffman coding. Okay. So Shannon Fano is the symbols arranged in order from the most probable of the least probable and dividing into two sets. So already we know that everything we have to dividing as a two sets. Everything we have to set 0 and set 1. So and we have to reduce the one symbol. Of course, this means the symbol's code is complete and will not from the prefix of any symbol code. So the algorithms work and it is produced fairly efficient variable length encoding when the two smaller sets produced by the partitioning are in the fact of equal probability. The one bit of information used to distinguish them is used most efficiently, and the Shannon Fano does not always produce optimal prefix code. For this reason, Shannon Fano is almost never used for Huffman coding to achieve the lower expected code word length. So when I'm using the Shannon Fano is that when it is in the implode compression method to apply the simple algorithms for high performance and minimum requirements for programming. So when I'm taking the probabilities of A0, A1, A2, A3 and I4. So how many are there? Total 5 symbols are there. How many probabilities are there? Means 5 probabilities are there. So how when taking the average probability means entropy is equal to summation I equal to 0 to 4. Pi means probability of log 2 of Pi. So when I'm finding out the entropy, we are getting the average probability. That is a bits per symbol. One symbol, how many bits are there? And after finding out, if I'm getting the 3 bits of this one, next what is a L average? L average means a 3 bit per symbol. So I'm taking the efficiency of the binary. Already we know that efficiency nu equal to H by L average. H equal to, in the previously we find out that H equal to entropy. H is nothing but a entropy. Entropy divided by L average. L average equal to 2 cube. Already in the final 2 cube equal to 8. So word length equal to 3. L average equal to 3. 2.0087 by 3. It is a 67%. After improving 98% we got. Okay, Shannon Fano is somewhat better in this. So it is an example 2. Here also Shannon Fano is applied, but 5 symbols and 39 total, 5 different source symbols are there. 39 total symbols are there. So what is the probability? Estimating the symbol probability from this one. Okay. So we are to finding out what is the code length of each one. So we are dividing as a code length are 2, 3, 3, 3, 3. And from the code word, we are converting into the average probability. That is a bits per symbol. We are finding out the entropy. Then average word length of EL. Then I am finding out the total length. So here source symbols are there, count is there, probability are there. We have to find out the total probability with entropy. So already we know that we are dividing as a 2 leaves, 2 symbols, 2 and 3. Anything we have to dividing as a 2. AB is one group, CD is one group. After then we have to divide again 2 groups. So AB is there and again CD is there now. So C is one group, D is another group. So it is finally ABC is one group, it is D is another group. So A, B, C, D is one group 2-bit, and E is the another group, that is a 3-bit. Okay, like this. Okay, so 2-bit of 15 plus 7 plus 6, 3-bit of 6 plus 5. So total value is 2.62. It is another example to finding out the symbols of Shannan Fano compression technique, to finding out the average value and the probability of frequencies. It is a level 1. We find out the probability of each one. So how many total 2 bits are there? How many total 3 bits are there? Okay, it is a Shannan Fano. These are the references. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.